Okay, pre-cal, this is your last video for 5.1. So last video for the 5.1 stuff. All right, we are finding exact values for each of these given an angle. So since these are 30 degrees, 60 degrees, 45 degrees, and 45 degrees, that's an indication that you need to think about your special right triangles because these are special right triangles. So when I consider a special right triangle here with a hypotenuse of 1, that means that sine 30, remember, is opposite over hypotenuse. So when my hypotenuse is 1, the side across from the small angle is 1/2. Don't erase though. Is 1/2. So that means that the sine of 30 degrees is opposite over hypotenuse, so 1/2 over 1. So 1/2 is the answer to this. Cosine of 60, well, I can use the same triangle. Cosine of 60 is adjacent over hypotenuse, so that is also going to be equal to 1/2. The tangent of 45. Okay, so I'm going to look at my 45-degree right triangle. Here, hypotenuse of 1. Tangent, remember, of 45 would be opposite over adjacent. It doesn't matter on this one which one is which, but opposite over adjacent would imply radical 2 over 2 over radical 2 over 2, and that's going to be 1. Okay, cosecant of 45, I'm going to use my same 45-degree right triangle, but cosecant, remember, is the reciprocal of sine. So what I'm going to do is I'm going to think in terms of sine, and then I'm going to find the reciprocal of that. So the sine of 45 would be opposite over hypotenuse, so that would be radical 2 over 2, which is over 1. And of course, it would just be radical 2 over 2. So the reciprocal of that, cosecant 45 degrees, is actually going to be 2 over radical 2, rationalize the denominator, you get 2 radical 2 over 2, which then reduces. So cosecant of 45 degrees is just radical 2. Awesome. Okay, now when you're finding the measures of the angle, now you're given the ratio of two sides and you have to find the angle measure. So you're kind of working backwards from what we just did on example 10. So if we think about the sine theta of 1/2, well, that means that the side opposite the 30-degree angle is 1/2. So theta here is going to be equal to 30 degrees. Okay, tangent. Now, tangent theta, this gets a little trickier. So I want you to recognize that since it's got radical 3 in the numerator, that indicates that we are going to be dealing with a 30-60 right triangle situation. Okay, because remember what my measures would be. So if I'm ending up with radical 3 in the numerator and a 3 in the denominator, that means that I would have had to, at some point, probably rationalize my denominator, which indicates that it is going to be the tangent of 30 degrees. So here, theta is going to equal 30 degrees. Now, how do I know that? Well, if it's opposite over adjacent, this means 1/2 divided by radical 3 over 2, which means 1/2 times the reciprocal, and I end up with 1 over radical 3, and then when I rationalize the denominator, see, I end up with radical 3 over 3. Okay, that's how I know it's theta equals 30 degrees. Okay, so cosine theta is radical 2 over 2. That means that theta has to be 45 degrees because that's my special right triangle that's a 45-45. Okay, secant, remember, is going to be the reciprocal of cosine theta. So if I think about secant being 2, that means cosine theta is actually the reciprocal of that at 1/2. So if you'll recall from our special right triangle, 30, 60, 90, the side across from the 30-degree angle is 1/2, and the the answer across on the other side is radical 3 over 2 and 1 for my hypotenuse. So cosine of theta is going to be adjacent over hypotenuse. So if that is the case, it's going to be 60 degrees because this is the adjacent side right there. So theta equals 60 degrees. Now, if you're struggling with these a little bit, it will be easier when we know more about the unit circle because we'll just be able to read these off of the unit circle. But I wanted you to see how much of a struggle this would be without the unit circle, so you will appreciate the unit circle more. You're welcome.